Hi everyone, today we are starting Unit 2 of Integrated 2, which is congruence theorems on triangles mostly. Okay, so to start off the section, the first section, 1.1, we are going to go over congruence theorems, but before we get to that, I want you guys to pause this video and try these two problems for warm-up before I solve them. Okay, so go ahead and pause that now. Now, once you come back, you needed to find the measurements of angle X and side Y. Okay, the first one that you want to find would be the X because that is the easiest. Okay, remember that the sum of the angles in a triangle, there's three angles, they have to add up to 180 degrees. So to find X, all I have to do would be 180 minus the 67.2 minus that 90-degree angle. So if I go ahead and do that, plug it in your calculator if you like, you get 22.8 degrees for angle X. Now Y is not as easy. Okay, now knowing that this is a right triangle, remember Y is your hypotenuse because it is across from that 90-degree angle. So to find that, you are going to use the Pythagorean theorem. Okay, I'm not sure if you guys remember what the Pythagorean theorem is, but it is a squared plus b squared is equal to c squared, where c is your hypotenuse and a and b are your legs. Okay, so for this problem, 5 would be one of the legs and 12 would be the other leg. So I have 5 squared plus 12 squared is equal to c squared. 5 squared, again, 5 squared is 5 times 5, not 5 times 2. You get 25 plus 144 equal to c squared. Add these two, get 169 equal to c squared. Now I need to know what my c is because in this case it would be y, right? That is in my c term. So to undo the squared, you would do the inverse, which is a square root. Now that's gone. So the square root of 169 is 13, which is equal to c, which is really equal to y in this case. Okay, so if you didn't get number 1 or the second part of it, go ahead and try number 2. So pause this video again, go ahead and try to figure that out. Okay, so again, just like I did in number 1, I'm going to find x first. So x is equal to 180 minus the 48.9 minus 90 from this 90-degree angle. And you get 41.1 degrees. That is my answer. To find y, y is a leg this time. The hypotenuse is 10. Remember, this is basically your c, and then your legs are either a and b. It doesn't matter. Okay, so I'm going to put y squared, since I don't know what that is, plus my b would be 6.6 squared equal to 10 squared. So this is a little different from the first one, but you are still using the Pythagorean theorem. You're still using a squared plus b squared is equal to c squared. So I'm going to do the same thing that I did last time, right? 6.6 squared will give me 43.56. So I have y squared plus that is equal to 100, because 10 squared is 100. Subtract both sides by 43.56. Cancels out on the left. I get y squared is equal to 56.44. Now to undo that squared, I square root it. Now I have y is equal to about 7.5. Okay, you can round it to 1 decimal point. That is fine. Now that was a warm-up, and I wanted you guys to see the Pythagorean theorem because the Pythagorean theorem you can only use with right triangles. Okay, and this is what the unit is going to focus on, right triangles. Okay, so for right triangles, how do we know when a triangle is a right triangle? Okay, the easiest one to see is usually when you are given a picture and you see this box right here. This is the first way, okay, or one way. If you see this box right here, or this little square, that means it is a 90-degree angle. Okay, so if you have a triangle with a box inside of it, it is a right triangle. Okay, that's the first way. Another way is if you are given that information. Okay, sometimes I'll give you problems where it says given, you know, angle A and angle B are right angles. Okay, so if I give you that information and A and B, or in one picture, an angle A is a right angle, then if you can create a triangle, then that would be a right triangle. Okay, now another way is if you're given information, but you're given something like AB is perpendicular to BC. Okay, so let's say I give you a triangle. Okay, A, B, and C. And AB is perpendicular to BC. If it is perpendicular, remember this means perpendicular. Perpendicular means that it creates two lines that intersect that will create a 90-degree angle. Okay, so if you have given information where they tell you that it's perpendicular, then it is automatically a 90-degree angle. Okay, so that would make that triangle a right triangle. All right, now we are going to talk about congruence theorems with right triangles. Now this will only work for right triangles, not a scalene or an isosceles triangle. It has to be right triangles. Okay, so the first theorem that we have is called the HL, or hypotenuse leg congruence theorem. Okay, and this theorem says that if the hypotenuse and leg of one right triangle are congruent to the hypotenuse and leg of another right triangle, then the triangles, both of those triangles, have to be congruent to each other. Okay, so I'm going to show you that on a picture. If the hypotenuse, remember the hypotenuse is always across from the 90-degree angle. So if these two hypotenuses are congruent and one of the legs is congruent, so let's say that this bottom leg is congruent to this bottom leg, then everything inside of these two triangles have to be congruent. That's the hypotenuse leg congruence theorem. Okay, the next one is the hypotenuse leg congruence theorem. I'm sorry, hypotenuse angle. Messed that up. Hypotenuse angle congruence theorem, the HA theorem. Okay, now this one states that if the hypotenuse and an acute angle, remember acute means a smaller angle, smaller than 90 degrees, an acute angle of one right triangle are congruent to the hypotenuse and an acute angle of another right triangle, then the two triangles are congruent. Okay, so again, hypotenuse across from the 90-degree angle. So they're telling you that if this is equal to this, okay, so those two sides are equal to each other, and an acute angle, so I'm going to say these angles right here are congruent, then these two triangles are congruent, and everything in those two triangles are congruent by the HA theorem. Okay, now, I do want to make a note that I use these angles specifically because they are angles that are across from each other, right? They're created by two lines that create an X, which means they are vertical angles. Every time you see a picture like this, you can say that they're congruent because they are vertical angles, okay? That is a property that you can use to prove triangles are congruent. All right, next one is the leg-leg congruence theorem. Here, it states that if the two corresponding shorter legs of two right triangles are congruent, then the two triangles are congruent. Okay, what I mean, essentially a triangle has three different sides, right? We usually say that they're legs. However, you have to remember that the longest side is always going to be the hypotenuse. Okay, so for this theorem, I don't want the hypotenuse. I want the other sides, or the other legs that are shorter than the hypotenuse, to be congruent. So I want the top to be congruent to the top and the right side to be congruent to the right side. If that is true, then both triangles are congruent by this leg-leg congruence theorem. And last but not least is the leg angle congruence theorem. This states that if the leg and an acute angle of one right triangle are congruent to the corresponding leg and acute angle of another right triangle, then the two triangles are congruent. Okay, so here you have two right angles, and you want a leg, not the hypotenuse, you want a leg to be congruent, so I can say that this leg is congruent to this one, and I can give you that this angle is congruent to this. So if I gave you that information, then these two triangles are congruent. Okay, now you can see, right, that this is a leg and this is an angle, so I have to be using the leg angle congruence theorem. Now be careful. This angle, although it is a congruent angle in both of them because they're both 90 degrees, you're not using that 90-degree angle as part of the leg angle theorem, okay? The right angle is only telling you that you are able to use one of those four theorems, okay? So without that right angle, you can't use any of these. And, all right, so that is it for this day of notes on congruence theorems. You did have a foldable to create in class, so if you don't have that, please ask me for it and I will give you an extra copy of it.